to this session, which is focused on the Object Pascal language and kind of where it is. I'm specifically focusing on the Delphi implementation of the Object Pascal language. And what I'm trying to do, first about myself, is just for clarity, I work for Idera, which is the owner of Embarcadero. I'm the product lead for IDE tooling, which includes like 4 or 5 different products, but my main focus remains RStudio and Delphi in particular. So that's how you can reach me. If you want to learn more about anything in this, I had to promote myself. Anything in this session, and all of the foundations, they're all in this book. This is not the last version. The last version, actually, you can download for free, the PDF from Embarcadero. But if you want the printed thing, this is the second last version, not much different. And it's, it's in print. So you can get it from Amazon. That's the only place, because it's self-published. Okay, so that's enough in terms of introduction. So what I want to cover today is quite a few things. And so, I don't know, I hope I'll have time. So I want to cover the language like from the beginning to the end. I'm going to go very fast on the core, but I want to touch on a few things that are specific to Object Pascal, which are not so obvious if you compare it with other languages. It's kind of common to compare Object Pascal with Java, C#, and other similar object-oriented language. C++ falls in a slightly different league, although there are lots of things in common. But there are some striking differences at the core of the language, which are actually quite interesting. And at times we get complaints, oh, you should implement this and that from other languages. But actually, there are core features of Pascal that other languages have never caught up, and they should, because they provide a lot of value. So I'm going to revisit the classic language. Again, I'm going to go very fast. Stop me anytime. I mean, shout, raise your hands. I can stop. I can show demos of everything, but I'm not going to. I'm going to spend a little time on the modern Delphi language, generics, anonymous method, and so forth, and then spend a little time on recent additions over the last 4 or 5 years. So let's start with the timeline. The language is alive and kicking. It's still very popular. As we kind of mentioned that yesterday quite a bit. So it has a great heritage dating back to Turbo Pascal. The compiler is a new version of Turbo Pascal. It's continuously evolving, but also trying to keep it Pascal. So we even get people asking, oh, why don't you introduce curly braces? I mean, really? I have to say no, and I get complaints, oh, you don't understand. Well, I don't know. So we get a lot of requests to implement any feature that's available on JavaScript, on other languages, which really don't make sense. Because a language you cannot just add any concept to a language. Some languages are evolving in that direction, picking everything in any other language and add it to it. At the end, it's like a complete mess. It's very confusing. So you need to evolve the language, but you need to keep true to the language tenets, the core, the idea, the approach, and so forth. Okay, so history, we've seen it yesterday, basically, so I don't want to touch more on it. So 83, 95, 2009 is where modern Delphi's Object Pascal started. But also, we introduced ARM compilers, and well, I like to point out inline variables because I think they're cute. So without, going too deep into the product, but there's one thing that happened over the last few years in the Delphi ecosystem that until 12 years ago, we had 1 compiler for Win32. And that's been true since Delphi 2 to XC2, XC3, something like that. Right now, we're shipping 9 compilers because some were retired. Like in all of the Apple 32-bit things are gone. So we have Win32, Win64, macOS for Intel and ARM. They're both 64-bit. We also had 30-bit ones. Linux, Intel, Android, which is still both 32 and 64-bit, iOS, ARM 64-bit device, and iOS ARM simulator. These are all technically different compilers that take the same source code, the same language, the same specification. The differences are really extremely minor across implementations. Of course, there are bitness differences. I mean, how large is a pointer, but that's natural to the language. So let me start with the classic language. Of course, the goal of the classic language is readability, it's elegance, it's nice, it's begin-end, it's operators, it's typing a for loop you can understand. I mean, every time I have to type a C language for loop, I have to think, okay, this is the increment, this is the test, are they reversed? I mean, come on, that's ridiculous. And I mean, calling functions a function by typing function is not a bad idea. I mean, you know that's a function and not something else. So I think there is value to this. You can get back to a 10 years old piece of code and read it and understand it. I don't think you get, I mean, I do JavaScript quite a bit, but I always had to read things 3 times. Of course, JavaScript has this funny thing that has equal, double equal, triple equal. I mean, yeah, good idea. I mean, how the heck that's confusing. But there are some core tenets which are very important. I mean, algebra call is strongly typed. It's more strongly typed than C, C++, because C++ having C inheritance does really weird stuff at the low level. It has a rich type system. Even the base type system is rich. I mean, how many languages allow you to define a type that is 1 to 10? No one. None of that. Oh, yeah, you can do. You have to say, oh, this is 1, 2, 3, 4, 5, 6, 7. Oh, come on, yeah. I mean, enumerating the values. I mean, this is a wonderful feature of the core language that basically no other language picked up, but I think it has a lot of value. It's very nice to use this. And range, sets are really more powerful. I mean, C# added sets at some point, but yeah, they're kind of okay-ish, but they're not as powerful as the sets. Distinct numeric character Boolean types, again, if you think about C and C++, that's a bit confusing at times. Compile time checks. Compile time checks are all over. Yes, there are things you can only catch at runtime with like range checks or other things, but everything we do, and everything we do for the new features like generics and so forth, it's heavily compile time check. And I mean, if you think about C# and their implementation of generic types, a lot of the type checks are at runtime. We do almost all of the checks at compile time, which makes the execution faster and more reliable, and so lots of good reasons. Faster execution and also safer code. Couple of words on strings, because strings are quite interesting. Yeah, they will move to Unicode and all of that stuff, but I had another slides I've skipped. Strings are extremely efficient in Pascal. Actually, I have to say that Python beats us at times, but it's one of the few languages that can beat our implementation. Strings are reference counted, and strings use copy and write. That's the big thing. I mean, so when you're passing a string as a parameter, you're not making a copy of the string. When you're assigning a string to a string, you're not making a copy of the string. But then if you assign a string to a string, and later on you go modifying one of the string items, you're not modifying both. It's not an alias. They are 2 distinct variables with 2 distinct values, but until you make a change, they have the same in-memory representation. As soon as you go, change the 6 characters of this string, then it makes a copy. It makes what is called copy on write. Whenever you're accessing and changing the value, it makes a copy at the very last minute. That's very efficient. A lot of languages these days, and a lot of languages with dynamic execution and garbage collection and all of that stuff, strings are immutable. That means either you can make a copy and that's efficient, but you cannot make a change, or whenever you make a copy, you're making a full copy, which is very time. I mean, suppose you have a megabyte string. That's a lot of effort. So string concatenation also is very fast. You say string plus string, and you put that in a for loop, it goes really fast. You can even speed it up by pre-allocating the size, but in most cases you don't need it. the code is fast enough that you can do it. And again, it's not trivial. I mean, in Java and C# you can do it. You cannot really concatenate your string. That doesn't work. It's not so simple to do string processing. And plus, we added the string helper, so you can do string dot call a method index of. That's an example. You can string dot something, so it behaves and looks like an object, but it's not an object. It hasn't got the inefficiency of being an object. But you can do dozens of operations of strings. So, like, these things are important. These things make a difference. Yeah, they're not like the shiny features of a language, but at the end of the day, it makes code faster, easy to write, easy to read, smooth. Other things we've added over time, we have added some core features. I call them non-classic because I've added recently. For in loops is a wonderful one. I mean, for in loops are very powerful. Not just because you can like do a for loop on a string, for characters in string, but because you can enable for loops on any object you have. So any object you have which is a list of something, you can write a special method, and with that special method you can do for object in my object center. You can write the code in the same way against any object. We have implemented it for a lot of things. You have components for the menu items in a menu, for the items in a list box. I mean, in a number of cases, we have it ready, but you can implement it on any of your data types. You can implement an enumeration. So that is powerful, because that's a nice way of expressing things rather than from 0 to items minus 1 or whatever. It's smooth, it's direct, it's simple. And of course, you can also avoid the two variables and put the variable declaration in line, but that's another topic. Exit with values, that's a small, nice thing some people might have missed. You can return a value by saying exit value, and so you have assign the result and exit in a single line. So, small thing. The other thing is scoped enumerators. Enumerators used to be global. The values of the enumerator used to be global. Now you can have a scoped enumerator that you have to say, like in C#, type name dot the value. You have to type a bit more, but it avoids polluting the global space with the same global symbols for enumerators. You don't have to use like multiple letters to make this distinct enough from any other enumerator with the same value. And so it's a great idea. It's compulsory in FireMonkey, not in VCL because there's too much code there. I would break a lot of code. But we made it compulsory in FireMonkey. Records. Record is something that people take for granted because, hey, we've had records since day one in Pascal. But records do a lot of things that are unexpected. Records allow having methods with private and public access specifiers, like a class. The main difference between a record and a class is that a class forces you to have dynamic allocation. A record, by default, uses local allocation. So if you create an object of this type, that's allocated on the stack or locally within the object hosting it. So there's no dynamic allocation. The dynamic allocation has a cost. I mean, an unlock of a block and releasing a block, and it has a small cost, but it has a cost. So if you're moving millions of objects around, in some cases, using records is more efficient. Tiny difference, but some people are a bit extreme in the performance, so it does make sense. Now, the other thing that records allow you to do is to define operators. So you can have your own record, as in this demo here, and say C equals A plus B, where it's my custom data structure. So it's nothing built into the language, but plus is mapped to class operator add, which you can define and write the code you want. They can even make a difference rather than addition, but whatever. I mean, yeah, you can do any crazy stuff, but in theory, you're expected to follow the rules. You can overload all of the operators of the language, anything, and, or, shift, whatever. Even the more obscure ones, not, unary and binary operators that are all supported. Plus, there are two special operators. They're called implicit and explicit, which allow you to define data type conversion. Specifically, if you're using implicit, you can convert a type into another type. Like, for example, there, what I'm doing in the second line is b equals 30. That doesn't make any sense. B is a record, 30 is a number. I mean, how comes I can assign it? Oh, because there is an implicit conversion from integer to t-point record that I've defined. So the compiler finds it, and it's going to call my custom code there, because the compiler cannot figure out how to convert one thing into another thing of a different size. Or explicit, meaning you have to make a hard typecast, like string of C. That's an explicit type conversion. You have to call for it, because otherwise the compiler might mess up. So these are extremely powerful features. I mean, implicit conversion means you can define data type conversion any type to any type. It doesn't need to be your record, actually. It's a bit, you can get a bit outside of the beaten path and define type conversion with types you're not defining as well. So anyway, core features of classes, I can spend probably an hour here, and I don't want to, but Delphi first introduced the concept of a property, which has later been adopted by many other languages, including Java, C#, and others. But they always require a method to implement a property. We allow direct field mapping, which I think is a better idea, because it's fast. Oh yeah, you can inline them, but come on, you can just map it. Property is a huge abstraction, because when using a property, you don't know and you don't care if there is a method, if there is a call, if there are side effects. So you're abstracting the access to something in an object, and you don't even need to know if there's going to method call or not. Lots of other features. Some of them are useless. I mean, the thing that I think are more useless is final methods. Final methods don't make any sense. They came to Delphi because C# had them. And why C# had them? They are totally useless in C#, but Java had them, so C# copied them, and then Delphi copied from C#. Come on, guys, whatever. It's fine. They're there. They're completely useless. Because, of course, in Java they make sense, because everything is virtual. So if you want a non-virtual method, you have to tell, hey, this is not virtual, because it's faster to invoke. We, by default, have everything non-virtual. So you have everything non-virtual. You declare something virtual, but you say, oh, but I don't want it to be virtual. I mean, yeah, OK, whatever. So there are lots of things we can say, lots of class data, class method with self, with class references. The entire thing around class references and class method is pretty unique to Object Pascal. It's not a common feature in other languages. That's the thing I wanted to call out specifically. I mean, there are books and books describing creation patterns in Java and C#. Yeah, it's one line. I mean, class reference, create. I don't think there are many languages that have this power. Yeah, at times with reflection, RTTI, you can build dynamic. This is as fast as compile. This is compiled code. There's nothing dynamic here. There's no, oh, let's see what the type is. No, everything is compiler is defined at the compile time. The compiler determines what to call. Yeah, maybe a virtual method, meaning it's actually late bound, but it's not that it has to figure out method name or anything at runtime. So this is very efficient, and that's a pretty unique feature in our language space, the ability to treat a class, a type, as a variable, and then process it with a number of things. You can call class methods, for example, but you can also call a virtual constructor, which is another pretty unique feature. Not many languages have virtual constructors. Virtual constructors are really powerful. So that's something I wanted to write. Now, I could spend a lot of time on interfaces, but I'm going to show interface demos this afternoon. Interfaces are powerful. You can have a class implementing multiple interfaces, meaning polymorphism is done multi-level. You can do is and as type casting. You can also do, that's been a recent addition, a reverse object cast. So go back from the interface to the object implementing the interface. That's something that was added a few years back. Interfaces use reference counting, but as we'll see, you can disable reference counting or morph it or use weak references and a bunch of other things. The other thing, it's been from day one, from the first demo, I mentioned yesterday, exception handling is really powerful, and you have nested exceptions, you have ways to dynamically configure the exception mechanism. It's really an extremely powerful concept in terms of the implementation, which I won't have time to go through. So, because I want to spend a bit more on modern Object Pascal. So, what has been added over, well, basically about 12 years ago, the language had a big transformation by adding, within a short amount of time, 3 core features: generics, anonymous methods, and reflection. So this is something I'm going to spend a little more time on, not a lot, because, well, that's the time we have. But the important thing here is that these features do not simply extend object-oriented programming. They offer different programming models. So they introduce new ways to write the architecture of your application. So it's more than just adding a feature to the language. It's really opening up to a new way to program, which you might like or not. It's optional. I mean, you don't have to buy it, but they really open up a lot in terms of what you can do and how you can do it. So let me start with generic types or parameterized types. Generics allow you to define the structure of a class without defining a class. And then when you provide the type, you have an actual class. So you're defining a family of classes, not one specific class. Now, one trick is that is one of the cases where, it's probably the only case, where the compiler makes an exception because type compatibility in Pascal is by name. Okay, so the types are compatible if they have the same name, which means if you have 2 implicit type declarations identical in 2 different places, you have 2 different types. They're not compatible. You cannot assign them. But for generics, because that would be very complicated, the rule is relaxed, and so generics are compatible by structure, not by name. So that's a bit of an exception to the rules. But other than that, generics are very powerful. You can have generic interfaces, you can have generic records, generic classes. You can have generic methods in non-generic classes. I have an example I'll show this afternoon. You can have constraints. So you can have a generic that doesn't allow any type, but only specific set of types. Only types implementing an interface. Only types inheriting from a class. Only types that are classes and not like native types. So there is actually a lot of very powerful features around generic, and yeah, of course, this went into standby mode. And I actually want to show a little bit of, the code is fairly trivial in this case. I'm going to show trivial demos this morning. If someone wants to join this afternoon, I'm going to show complex demos this afternoon. Okay, yeah. Come on. No, I don't want to say, I don't care about that image. So, this is a very trivial example of a generic type. I have a key, which is a string, and a value that is something. It's t, so I don't determine the type. I can use the generic type as a parameter, as a field value, as a property value, like anywhere you can expect a return value. That's not an example here, but I could create one, and so forth. So this doesn't define a class, but it has code. Of course, it has code that cannot imply a specific type because we don't know what type it is. If we need to do any specific operation, like call a method, create an object of the type t, then we need to use a constraint. If we constrain the type to an interface, we can call any interface method on the generic type. If we don't, we can do almost nothing, rather than copy things around and basic stuff, okay? So in fact, in do something, I don't know what to do. I mean, there's almost nothing I can do because it depends on the generic type. Although I have to mention that there are some specific functions for generics. So these 6 functions you can apply to a T object For example, you can assign a default value, which, depending if it's a class, an integer, a string, or whatever, would be a very different thing you're assigning. You can have type information, size of, so how big T is, depending on the type you've been assigning, and so forth. So there are a few things you can do, but it's fairly limited unless you put a constraint. But getting back to the demo, again, this is a fairly trivial piece of code. So what you can do, for example, you can create a generic, an instance of this class based on integers. So that means that the value, the key is a string and value is an integer. You can assign an integer to it. Or you can have a generic that the value is a component, means you can assign a component as value. Of course, you cannot mix them. I mean, if it's a component, it's not an integer. So you can never mix generic instances that are done or implemented in a different way. And this is strict. So if you look at value, in theory, we should say that we're using system object as value. So it's a specific type. And even the design, I mean, in the editor picks up the actual type for this value. Okay? So what are these used for? I mean, containers is a classic example, but you can create fairly sophisticated data structure with generics. If you want to have some fun and look at advanced generics, I recommend looking at Spring4D source code. That's pretty extreme, but it has a marvelous use of generics in the language. And again, I'm going to show a couple of other demos in the afternoon. The other thing that was added, maybe. Okay, it got. Oh, come on, stay here. Okay, is anonymous methods. So one way to see anonymous method is they're like method pointers, but they're type safe. That's one angle. I mean, the language. I mean, Object Pascal never took off any of the core Pascal features, including the ability to have a function pointer. I mean, function pointer is a feature any core language has. I mean, C or Pascal, so it never went away. But it's a bit unsafe to use, it's a bit risky and so forth. Then we introduced method pointers, which is used for event handlers and all of that stuff. And then there is another thing, which is anonymous methods, or the term closure is the term used in JavaScript. JavaScript, I mean, you cannot write 3 lines of JavaScript without a closure. I mean, they're really the way to write JavaScript code, for the good or the bad. So that's where the terms come from. Now, there are two things that are very specific to anonymous methods. One is they support an inline declaration. So you can pass, when you need to pass the function as a parameter, you just write the code there, in place, rather than somewhere else, give it a name and call by name. The other thing, and you might say, well, yeah, it's syntax sugar. No, it's not, because anonymous method can capture the execution context. So they can capture variables that are visible when they are declared, which I know it's complicated, but I'll see if I can help, explain this with the demo. Yeah, it's not in the right sequence, but it's fine. No, I want to save change. Okay, so let me start. So what is this t-int proc? This is just declared as, this is how you declare anonymous method type. And by comparison, this is the one below is a method reference type used for events. So it's just reference to procedure, or reference to function if there is a return value, and then the parameters. Everything is type check at compile time as usual, so no surprise. So once you have something like this, what you can do, and I didn't want to get here, let me get back here. Okay, you can write something like this. You can define an integer procedure, You assign to it a piece of code, what looks like a piece of code. Well, in fact, you're assigning code to the variable, and then you can call it unint proc22. Yeah, okay, but it's kind of pretty useless. I mean, why do you want to do something like this? The other thing you can do is you can have a function that receives an anonymous method as parameter. Now, in this case, things get a bit tricky. So this call twice function, if we look at it, it receives a value and some code and execute that code. Oh, actually passing the value as parameter. But that doesn't need to be. I mean, it could be any parameter, but just for the sake of the example. So it's calling this, increasing the value, and calling it again. Fine. So, but the interesting thing is that we can customize the entire execution. So call twice can do anything because I just called something twice, but what is it calling? In this case, it's calling increase a number by n. Now, look at what's happening here. What's a number? A number is a local variable here on the stack. It's just declared above. But a number will be visible inside call twice. So call twice can use a number, can capture a local variable and use it alongside, which is a bit weird, but that's how the capture mechanism works. Now there's another case which I'm going to actually execute, which is a bit more extreme. So let's look at what I'm doing here. The code is slightly different, but doesn't really matter. So I have a number, I assign a value, and then I assign closure that uses a number. Does a simple thing, increases it by n, and displays it on screen. So easy stuff. Okay, is this doing it? This is doing nothing. This is not display. I mean, I'm not executing this method. I'm saying, oh, this is the value, this is the method. Stop. I have another piece of code. It's a separate piece of code because this anonymous method is a local field of my form. So I have a separate case where I'm calling it if it's assigned, just for safety. So I call, okay, call this anonymous method pass 5. And again, this is a local field in the form. So look at what's happening here. And I think this is a little too small, sorry. Well, so I press store, and I get nothing, because we're not executing anything, we're just assigning stuff. Then I press button call, and I get 8, 5 plus 3. I press it again, I get 13, 8 plus 5, and so on, and so on, and so on. Okay, where is that value stored? That's a number, the a number variable. Oh, a number variable was on the stack when I click the other button, and it's gone. So I'm using a variable that apparently is not available anymore since a lot of time because I've been clicking this thing. So that's the idea of capturing the execution context. If an anonymous method touches some variables, objects, fields, and other things, it captures them, it stores them inside an implementation interface. It's a lot of technical details that you don't need to care about too much. But it captures that value. That value becomes, is implemented in a completely different way now in memory. So it's associated with the anonymous method, not with the original location where you declared a number. So that makes it a very powerful concept. Makes it also a bit complicated to use and scary at times, but it is a very powerful concept. Okay, then things can get also a bit extreme, but I'll, like this is a fairly extreme case where you're symbolically calling, indirectly calling a method. It's fun because you can have a function that returns an anonymous method. Like this would return an anonymous method as a result. So result is code. I know it. And again, not executing it, is returning the code. It's not executing the code. So it's not executing the code and then returning a value. It's returning the code as closure. Again, opens up a ton of opportunity. It's complicated, it's not trivial. I have to say adoption, even after 10 years, has been limited because this goes a bit outside of the comfort zone from a lot of Delphi developers, but it is a very powerful feature. We have started using it in some libraries, in some architectures, and it is very powerful. Last thing, which is equally powerful, is reflection. Delphi was one of the first few languages to implement a runtime system for the streaming system, for the creation of forms. There is a fairly complicated streaming system associated with the published keyword, which is, again, a unique keyword. Generally get public, you can get published in other languages. So there was a lot already in the language which allowed for a lot of flexibility. For example, recreating objects out of a streamed image, out of a set of configuration files that, if we were to build it today, would have been probably JSON or some of the other modern formats. It's that format because it was done 25 years ago. So it's like a very specific format, but could be easily mapped to something more modern. But again, that was the old way. The new way is that if you enable runtime time information, you can have dynamic access to fields, properties, and to methods, which is something Java provides with reflection. C# provides to some extent, but it is possible also with compiled code. Now, when you are using RTTI heavily, you are basically building an interpreted layer or a slow execution layer on top of the core language. So when you're using RTTI, your code becomes as slow as an interpreted language. Because you're looking for a name of a method and then say, hey, yeah, find it, call it. So it is slow. But it provides a huge amount of flexibility because you can allow, in extreme cases, someone to type like the name of a property of a method and invoke it. And something you can do with compiled code, because unless you have like a gigantic case statement or if then with all of the possible scenarios. So it's fully runtime enabled. Now, there is an add-on feature, again, something a lot of languages provide in different ways, which is attributes. So not only you can call methods by name and so forth, but you can decorate elements. You can decorate a class, you can decorate a method. Your decorators can have parameters for further flexibility. And then what you can do at runtime is you can say, hey, I want to use this class only if the class has this attribute. I want to call the method of the class that has the simple attribute. So rather than invoking directly a class, rather than invoking a virtual function in a class or a derived class at runtime, with late binding, you can say that one class has a method called procedure called 1, the other has a procedure called 2, but because I decorate with the same attribute, I want to dynamically call the function, the procedure with that attribute, regardless of the name. So you're not binding by name at runtime either, you are binding by attribute, which is really powerful. You can really do a lot of things. A classic example is XML mapping decorators, JSON mapping decorators. Whenever you need to, database mapping with decorators, you can have an object mapped to a database, and you can use attributes to say, this goes into that field, this uses that data type, and so forth. So this can be really extremely powerful, can radically change the way you write code. And the demo I have doesn't give this full justice, but it's for the time I have. But what I'm going to show is a couple of simple dynamic access scenarios. No. It's fine. And I'm not showing a full example with attributes, only a basic one for now. So what is this code doing? Okay, first, it's looking for a type for the T-button type. T-button is T-button, but there is an in-memory representation in the RTTI system for everything, including the data types. In fact, there is T-RTTI type data structure. That's what I'm saving here. Then we can ask to the type, hey, do you have this a property called text? And again, I'm binding my string, so slow, error prone. If I mistype it, I get a runtime error. Yeah, be careful. And again, this is slow, but it's something you can do otherwise. So looking for a property. And the third thing I can do, once I have a property, I can get the value of the property for one specific object, which needs to be a button, otherwise I'm getting in trouble. So sender is the button here. So I'm saying for this object, access to the value of the property, and what you get back is t-value. T-value is a very interesting data type. It's like variance done right, because it's a type-safe implementation of multi-type value. So a value can have any value. It can be a string, an integer, or anything. But once you assign a value, you can only read the exact things back. So if you're assigning an integer, you can only read an integer. You cannot read a string. Well, you can convert everything to string, but that's separate. So what you're putting in, you are taking out. Because when you're assigning a value, it's going to say the value, and this is the type. And when you're reading, say, am I reading the right type? If not, raise an exception. Unlike variance. Variance convert everything to everything and can do a fairly big mess. So this is the idea. So now I can extract the value of my text property of the button. Of course, writing sender.text would have been so much faster, but it's hard-coded. It's what it is. This text value can come from a database configuration, INI file, user input, anything. So I'm calling by string. The same can be done with field types. So access is available for everything, including private fields, by default, which is a lot, which actually adds to the size of an executable. There's a lot of metadata. The other thing you can do is you can invoke methods. So this is a slightly different scenario. Well, actually it's two, but let's suppose show. So what you can do is to get a method. And again, you get a method, which is a TRTTI method. A method has an invoke method. So you can call a method. You can call any method, any public or published method, not the private one. Any public method, you can call it by string name. How do you pass the parameters? Oh, okay, you define an array of t-values, which has to match, in number, the number of parameters expected by the function. If it doesn't match, you get an error. It's not like you get some random data in memory. If you don't provide enough parameters, it's going to check the number of parameters compared to the expectation, and it's going to raise an error. So in the first case, we are not passing any parameters, so I'm passing an empty array. In the second case, I have one parameter, I set the length to 1, I pass the 0 value, and then I can pass hello to my show function. So it's very powerful. It really opens up for a lot of things. A demo I have that might be able to get to this afternoon is a demo where you can type text to create forms, add components, change their properties, do almost everything. Create an application dynamically just by typing the code with the full scripting kind of language. The language is poor, but whatever, full scripting scenario. This is important because as much as we want the code to be compiled, because compiled code is fast, secure, robust, blah, 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 there are cases you need flexibility, you need dynamic behavior, you need dynamic invocation. And so if you need dynamic invocation, you shouldn't say, oh, give up, let's go Python, let's go JavaScript. No, you can still stick to Delphi and create your own dynamic layer, scripting layer, and add it to the core. Okay, with that, what's the time? Okay, let me continue. I think I'm going to go quick on this. The other thing we have not done to the language is adding at the language level support for multi-threading. Some languages added full multi-threading support at the language, which I can understand. Multi-threading is tricky. I think Primož is going to explain that at length, so I don't need to do much here. Threading is complex, and my personal view is that a language should not encourage threading for the sake of doing threading, because if you don't know what you're doing, you really make a mess. And a mess that's hard to find, impossible to debug, depends on deployment conditions, depends on runtime configuration, so it's a mess you don't want to get to, unless you know what you're doing. So what we decided in Delphi is not to add threading at the language level, but had core tenets that abstract threading. And basically what we have is an entire architecture. It's called Parallel Programming Library, which uses thread pooling. So it creates threads as needed by the system, depending on the CPU power level, consumption. So it has a very sophisticated threading allocation logic. Of course, it works across all platforms. And it exposes a few handy features. One is parallel for loops. Parallel for loops are nice, and so we provide parallel for loops. The other is abstracting the concept of thread in the concept of task. A task is, well, similar to a thread, is a piece of code based on an anonymous method you can execute anytime you want by invocation. And you can schedule a bunch of tasks, and the task will be assigned to the thread depending on the CPU capabilities and power and level of CPU usage and a lot of other things automatically. The other thing we expose is futures. Futures are values you can compute when you have time. So rather than saying, I want to execute this expression and get a result right now, blocking everything else in the main thread of the CPU, you can say, oh, I need this value. Oh, compute it when you have time, and in a separate thread. And then at some point you need the value, and when you read the value, if it's not available, it's going to stop the application until it's available. But if it's already available, the application keeps going. So this is provided by the system threading unit. This is an example of a parallel for. Again, I don't have enough time to delve into this, and well, threading will be a subject of a bunch of talks later. But this is the basic idea. You write something that's very similar to a for loop. Yeah, the syntax is different, but the concept is similar, minimum, maximum. And then you provide the anonymous method, which is what you want to execute. But you need to be careful, because this is multi-threaded, so if you're touching a global variable like this total, you need to be careful, because of course the two threads could conflict in accessing the same. In this case, rather than inc, I'm using an interlocked increment, which is thread safe. So the threads will wait one to the other if they need to increment the same value. Again, there's a lot to be said here, but that's all the time I have. Record helpers is another addition to the language, was done some time ago. You can have class helpers, you can add methods to an existing class. You can have record helpers, you can add record methods to an existing record, and you can have intrinsic helpers which can add methods to a basic data type. Like with an integer helper, you can write 10 dot to string. This works, it compiles, no problem. Not your father Pascal, it's a bit different. And that's, I mean, we would provide intrinsic helpers for a lot of the native types, but you can provide your own, and you can provide it for any data type. You can override ours with yours if you want, and replace them. So it is a very powerful mechanism. Okay, I think I'm going to skip dynamic arrays and this one as well, because I want to spend a little bit of the remaining time touching on a couple of things that were added more recently to the language. One is the thing I was mentioning earlier, is more flexibility for interfaces. Interfaces use reference counting. Interfaces use reference counting as a built-in mechanism, so you don't have, unlike objects, you create an interface, you use it, when it goes out to scope, the object behind the interface gets destroyed automatically for you. Of course, if you have two references, because you assign the interface to another interface, when both goes out of scope, the object is destroyed, otherwise you're in trouble. And that happens, like it happens for strings, it happens for interfaces. Now, there are cases where this gets tricky. For example, if you have an interface cycle, if you have a parent and child object, and they have interfaces crossing each other, the reference count will never get to 0 because, hey, there's always at least one reference because they reference each other. So you can have an interface cycle that's lost in memory, unreachable, but it's going to keep using memory forever. So what you can do, you can use a weak reference to break interface cycles, reference cycles. So if a weak reference does not increase the reference count. So you have this cycle, one of them has to be weak, and then they have a reference count of 1, 1. When the external reference goes out of scope, the two objects get destroyed. On the other hand, weak references are fully managed, meaning that they know the object. I mean, when you have an object reference in Pascal, in Object Pascal, if you destroy the object, the reference remains some address in memory, and if you try to use it, well, you get an access violation or something, or maybe it works. I mean, you're using a dangling reference, something that is randomly pointing to somewhere in memory. Very risky, very dangerous, something you have to be careful about. And there are techniques in Delphi to handle it. But with a weak interface reference, it's managed, meaning you have this reference to this object. If for any reason the object gets destroyed, your reference gets set to nil automatically by the system. So that means that you can always say, oh, if assigned, my weak reference, do something with it, because it might get unassigned like behind the scenes. So it's a very powerful mechanism for managing memory, and something I really recommend, spending some time on to. There is also another option. You might want to say, I don't care at all about reference counting. Okay, fine. You can declare an unsafe interface reference. Unsafe meaning no reference counting, not managed, not anything. If that goes if the object is destroyed, it's your problem to figure out. So it's complete. It's just a pointer or a good old object reference in terms of behavior, but it is an interface reference nonetheless. So that was a big change. The other thing, is that the one I have a demo for? I know I had another demo I wanted to show. Oh, no, wait, not here. Let me open. Oh, no, it's a different one. Well, let me open it anyway. Let's see if we can get to it as well. So sorry. Inline variable declarations, as I was mentioning yesterday, it's a very nice feature. It looks like syntax sugar, the fact you can declare a variable where it is used rather than before the begin statement. And yeah, we got complaints because we are breaking the rules of the Pascal language. But this is a very interesting change. First, you can declare and initialize. Separating declaration and initialization is a problem and it's a risk for a language because, I mean, when you are at the begin statement, you have a lot of uninitialized variables. And, well, yeah, the compiler is going to warn you, or you haven't initialized it, but still, it's something at times you might not, I mean, it's not great programming practice. So you can initialize at the same time. The other thing you can do, you can have them inside local scope. So, for example, loop variables in the language, I mean, you declare them traditionally in the, before the begin block, then at some point you have a for loop for I equals. That I is valid before the loop, but maybe you haven't initialized it, and is valid after the loop, where it's, oh, is it like the maximum value plus 1? Actually, the compiler warns you, say, you shouldn't touch it. I mean, modern compilers, but it's a risk, and it doesn't make any sense. That variable, that I, makes sense to exist only within the begin end of your for loop. And this is what this syntax does. When you say var I within the for loop, when you go to the end statement, if you try to use I, say, oh, unknown, I don't know what it is, it's not visible, because the visibility of the variable is limited to the loop. Also within a loop, I mean, in any begin block, you can declare a variable that's local, has local visibility to the block. Something you can do in C, you can do in many other languages, you couldn't do in Object Pascal. Not only the visibility, but also the lifetime. If you have, for example, an interface which is managed, or a string which is also managed, and you declare it in the block, when you get to the end statement, that object, that string, that interface is going to be removed from memory. It's going to be initialized, like it generally happens at the end of the function block. So lifetime and visibility are different. So, and this is not a simple thing. I mean, it's probably the first time since ages that we have introduced in the language a new visibility. Because visibility has also been global, function level, nested function level, and a few other things. But this is a brand new concept of visibility. So it's very relevant. The other thing which is very nice in cases is type inference. So there I've declared var I colon integer, but I could have omitted the colon integer. I could say var I equals 1, because, hey, 1 is an integer, so the compiler can figure out. Yeah, you're saving typing like a little bit, but that's not a big deal. But look at the thing below. My dictionary is a T dictionary string integer. That's a lot of typing, and I'm not typing it. I'm using that because I need to pass it to the create function to create an object of that type, but I'm declaring my dictionary as, oh, the type of the objects being assigned to, which is T dictionary string integer. So you don't need to declare the type of the variable of my dictionary. It's inferred from the context, from the assignment context. That can save a lot of typing, and also, let's suppose they say, oh, I don't want integer, I want native int. You don't have to go changing that like a million places, because the less you type a specific type, the less you have to fix it when something changes. So it gives you some flexibility. So again, inline variables are not just a trivial extension to the language, just, oh, yeah, I can type this here rather than here. It's really a profound change to the language. But there's another thing I want to mention, and that's going to be my last demo, and, well, not last topic, because there's very smallish things at the end, which is custom managed records. Custom managed records, if I have one here, are a very sophisticated concept that was introduced fairly recently. What's the idea? I mean, records, as we mentioned, are very powerful, because records allow you to add methods, to add operators, to add type conversions. So they provide a lot of features and capability, and they stick with the traditional model of local allocation. So lighter on the dynamic memory management system. But the problem is, okay, what if I need to initialize a record? Well, yeah, you can call something like create and add something to it. But the problem is that because a record is initialized and finalized intrinsically, you don't have method.free, a record.free. It goes out of scope, and the memory is gone. And again, even when you're declaring a variable, it comes in scope. And it has an initial value. All zeros, random bytes in memory, probably random bytes in memory. So what you can do with managed records is define an initialize method and a finalize method, which are automatically invoked when you type something like this. Oh, sorry. So look at this code. It's insane. I'm creating a record and I'm getting a value from the record. That doesn't make any sense. Well, yeah, in the traditional sense, yeah, it doesn't make any sense. But what's happening here is that var tMyRecord gets initialized by calling the method I provided, which sets some random value, I think, to value. And then when I go to the end statement, the one below log, that gets cleared, and I execute some other code to finalize, in case I need it. I mean, if I don't need it, I can omit it, but that's the idea. And so and the other thing I can do, which was there, is define an assignment operator. So I'm overriding another operator, which is : equals. Or, because the same happens in terms of record assignment, when I'm passing the record as parameter to a function, I'm making a copy of the record. And again, I'm assigning the record. So for those scenarios, I'm making a copy of a record, I'm doing : equals, you can define, again, what happens. Because there might be metadata that needs to remain unique. There might be a link to an object that you want to make a copy of that object, not have two references of the same object. So there are many things you might want to do that go beyond take these bytes and copy these bytes over, which is what a record assignment would do automatically. So again, the demo goes on and shows a bunch of things. It's even in the book, and it's on GitHub, and so forth. So easy to find it. Actually, I think I can. I thought I had. I'll get to it later. Okay, so last thing I want to mention is a couple of smallish things we did in terms of syntax sugar. That's really syntax sugar. There's no intrinsic value. So one thing is introduce the separators on the for numeric values. So you can type 1,000,000 and use underscores to make it readable, basically. Well, you can put underscores where you want. Doesn't really matter. But it's just a syntax help in making variables more readable. That's something we actually copied from C#. The other thing, you can have Pascal always had the ability to define a constant as an integer, hexadecimal or octal, for those who know what an octal number is, which are probably not many. But now you can define a binary literal, so just 1 and zeros, and that's what you get. You get exactly that binary number converted to an integer, because ultimately you want an integer, but it's a way to represent that binary number. Okay, so Object Classic, great language, a bit of a secret. It's good for learning. It's very powerful. It has unique features not found easily in other languages. It's still used throughout the industry. And, well, that's something we covered yesterday as well. The last thing I want to mention, though, and I will be done after that, is if you go to, if you go to GitHub under Delphi sessions, you can see a bunch of language-based. This Delphi language session has a lot of code, including some of the demos I was showing. Some of them I'll show this afternoon. The other thing you can do, though, and I always get confused because I'm not logged in here. Yeah, okay. This is everything in the book. So it's like couple of hundred demos of the language, including some of the things I was covering. So just go Marco Delphi books on GitHub, and you can find a lot of stuff there. Okay, that's it. Again, that's what I wanted to show. And yeah, a couple of minutes late, but should be good.